Anyone, any doubts in the plane scale or diagonal scale?
No, sir.
Okay. So
Sir,
I'll
just
start.
can you explain in brief, sir, from first figures?
Of which one? Which problem? Plane
Second
scale
one.
or diagonal scale?
Plane scale, sir.
Plane scale, second problem. Okay. Yeah. So generally, if you take a normal scale, this normal scale consists of 1 to 15 centimeters. And if you want to measure anything such as 8.7, so what you have to do is you have to divide between 8 and 9. Between 8 and 9 centimeters, you have to divide 10 equal parts. And we can generate this scale. But if you want to create a plane scale, what instead of dividing in between 6 to 7, 7 to 8, 8 to 9, 9 to 10, what we do is we divide only the first centimeter, first main unit. This is our main unit. Main unit is centimeters, subunit is mm. On the normal scale, we can measure one main unit and one subunit. Least count is subunit. But in plane scale, what we do is instead of dividing all the parts, what we do is we take the first main unit. On the first main unit, we divide into subunits. This main unit we divide into subunits, and first one we mark it as 0. And if I want to measure 7.5, what I do is 0 to 7, I will highlight. And from here, I will highlight the fifth one, so that I can generate my 7.5 if I want to measure. If I want to measure 10.5, then what I do, from 0 to 10, I will highlight. And from here 2, I will highlight, so that it will become 10.2. If I want to measure 15 mm, what I do is 0 to 14. We first one we mark it as 0 to 14 centimeters, and 0 to 10 mm is 1 centimeter. So total will become 15 centimeters. So like this we use in the plane scale. And before starting, you need to know what is meant by what is the distance to be measured. First, you have to know what is the maximum length of the scale. So here the maximum length is 15 centimeters. So you can't cross 15 centimeters on your created scale. You can measure anything below 15 centimeter only. If you want to measure more than 15 centimeters, you have to use another scale. But whatever the scale you have created, maximum length is 15. So maximum 15, you greater than 15, you can't measure. So before creating your scale, you need to know what is the maximum distance. So maximum distance I can measure on my scale is 6 meters I have to create. And what is the distance I'm measuring? I'm measuring only 4.7 meters. I'm measuring only 4.7 meters on my scale. So because your sheet is around 280 mm, you can't measure meters. So that's the reason what we do is we reduce the scale. So we need to know the RF value. What is meant by RF value? You have to know. In this problem, directly they mentioned RF value as 1:40. So directly they gave RF 1:40. And you know, you have to calculate what is the distance to measure. Distance to measure is 4.7 meters. You have to divide again. 4 meters plus 7 decimeters. You have to divide. So in our scale, main unit is meters. Main unit is meters. Subunit is decimeter. Similarly, we have to know what is the maximum length. This maximum length, whatever may be the length, it is in meters, inches, feet. You have to convert into centimeters. Every time you have to convert maximum length into centimeters. Whether it may be yards. Suppose they gave that 3 yards is the maximum length. You have to convert yards into centimeters. That conversion already given in this one. How to convert already gave. If you want to convert yard into meters, convert, if they measure 3 yards. 3 yards is 0.914 meters. Again, this 1 meter, you have to convert into centimeters. 1 meter equal to 10 square centimeters. So like that, you have to make the conversions. Whatever may be the maximum length, you have to convert into centimeters. And because you want LOS in the units of centimeters, so that's the reason. If the maximum length is in centimeters, you will get the LOS in centimeters. So that's the reason we'll convert maximum length into centimeters. And we have to know the least count. It can measure up to 1 decimeter is the least count. LOS, you have to calculate RF into maximum length. 1/40 already given in the problem. 1/40. If it is not given, you have to calculate the what is the RF value. You have to calculate. Then you have to multiply by 100. 1 by 40 into 6 into 100, because 1 meter equal to 100 centimeters. You will get the value as 15 centimeters. Then what you have to do is you have to draw the LOS. AB distance equal to LOS. AD distance equal to 5 mm. In the plane scale, we take 5 mm. In the diagonal scale, we take 50 mm or 60 mm, depending upon the problem. LOS will be 15 centimeters. You have to draw the 15 centimeters. And this 15 centimeters, you have to divide to maximum length. It is 6. You have to divide to 6 equal parts. And first part, we have to marking as 0, because if you're marking this as 1, then you have to divide all the parts. It takes so much of time to divide each and every part, main division. So that's the reason what we do is we divide only this part. First part we divide, and we divide this into 10 equal parts, because 1 meter equal to 10 decimeter. So that's the reason we divide into 10 equal parts. And now I need to measure on my scale. I need to measure 4.7. On my scale, I need to measure 4.7. So 0 to 4, I will highlight. And then from here, from the decimeter scale, I will highlight 7 decimeters. So 4 meters plus 7 decimeter, it will become 4.7 decimeters. Okay. So you have to represent 4.7 meters separately, 4 meters separately, 7 decimeters separately. Okay. And coming to the next problem, in this problem, they didn't give RF value. They didn't give RF value, and you have to calculate RF value. So how to calculate RF value already given in the previous slides. RF value equal to drawing length. What is the length you are drawing on your drawing sheet by actual length of the object? Suppose the actual length of the object is around 10 meters, but in the drawing length you are assuming that 1 meter equal to 1 mm. So if the 10 meters is the length, actual length, then drawing length you are drawing only 10 mm, because you are assuming RF value as 1 meter equal to 1 meter equal to 1 meter equal to 10 mm you are assuming. So that's the reason you are using this one. So here you have to calculate. So when you draw 1 centimeter on your drawing sheet, it represents 4 meters of the actual object. That is the problem they gave here. And maximum length you can measure is 50 meters, and you have to find RF. And because the maximum length is 50 meters, you can measure only less than 50 meters, and you are measuring 36 meters. And you have to divide this 36 meters into 30 meters plus 6 meters. Okay. The drawing size, actual, whatever you are drawing on drawing sheet is 1 centimeter, but actually it represents 4 meters. So 4 into 100, it is 400 centimeters you have to make. So the RF comes as drawing size by actual size. Drawing size is 1 centimeter, actual size is 400 centimeter. Here centimeter get cancelled, so RF comes as 1 by 400. Okay. And maximum length to be measured. So here you have to measure 50. So this 50 meters, again you have to convert it into centimeters, because LOS you have to make it as centimeters. So 15 to 100 centimeters you are making. You have to find the LOS. RF into maximum length. RF is 1 by 400, you have calculated. Multiplied by 50 meters into 100, so that it will convert into centimeter. So after calculations, you will get 12.5 centimeters. So now AB distance, the horizontal distance is 12.5 centimeters. You have to draw a horizontal line of 12.5 centimeters, and you have to divide this 12.5 centimeter into 50 parts, because maximum length is 50. So if you divide a line and make it 50 is a difficult. So that's the reason what we do is we make it as 5 equal parts, and we assume that one part equal to 10 divisions. So here we divide, because we have to measure the 50. So we divide into 5 equal parts. We divide the LOS into 5 equal parts, and we assume each part is 10 meters. Okay. So first one 0, 10, 20, 30, and 40. We have created this scale. And again, we have to divide one main division into subdivisions. So again, this is a 10 meter scale. 10 meters I am dividing into 10 equal parts. So I'll get 1 meter each. Okay. So 0 to 30, I have to highlight 30. And from here, I have to highlight 6. So 30 plus 6 total becomes 36. Okay. Yeah. Any doubts in the plane scale? You can unmute and you can ask. So I have to represent 30 meters separately, 6 meters separately, and 36 meters separately. And here you have to write RF value. What is the RF value you got? what is LOS value you got, what is the main units, and what is the subunits you have to write. Okay. And no need to draw the third one, fourth one, and fifth one. In the plane scale, draw only 1 and 2. In the diagonal scale, draw only one problem. In the Vernier scale, draw only one problem. Okay. And the next is the diagonal scale. In the diagonal scale, what we do is, we are measuring 3 consecutive units. Continuously 3 units we are measuring. Okay. So what we do is, this is a line. This line I have to divide into 10 equal parts. It is, if it is exactly 1, you can divide. But if the line is very small, like this is the line, and if you want to divide this into 10 equal parts, it is difficult. So that reason what we do is, we take the diagonal principle, we draw the vertical line, and this vertical line we divide into 10 equal parts, and we join this part to this point. And if you join them, it will become diagonal scale. So if I want to measure, this is the distance, exactly half will be at the center. So how to know this center is, I will be drawing a AB line. I'll draw the vertical line. I will divide it into all these parts. And if I measure, then I will extend this line to diagonal. I will draw the diagonal AC. This is my C point. And if I project this one, this distance is 0.9 of AB. If I project this one, this distance is 0.8 of AB. Similarly, if I project this one, this distance is 0.5 of AB. So however may be the smaller line, we can divide into 10 equal parts if we use the diagonal principle. Okay. So if you want to measure consecutive 3 units, if you want to measure directly 3 units such as meters, decimeter, and centimeters, you can use. If you want to measure yards, feet, and inches, you are creating a scale such a way that you are measuring 3 consecutive units: main unit, subunit, and sub of subunit. Then you have to use this diagonal scale. Okay. So same explanation. So 9 to 9 dash will be 0.9 of AB. Okay. Principle of diagonal scale can be asked as a 2 marks question in your exam. Okay. Then construction. So if you understand the plane scale, what we do is, we are creating the same plane scale and we are dividing this into 10 equal parts. Okay. Same plane scale we use. On the plane scale, we create the diagonal scale. So what we do again here is, we'll divide this one into this parts, and I will divide this into 10 equal parts. So this is my main unit. This is my subunit. Here I have to write subunit, and here I have to write sub of subunit. How to divide no sub of subunit is, this is my 0th point, this is my first point. This 0th point will touch to the first point, and this 1 point touch to the second point. This second point at the bottom will touch the third point at the top. This 4th point at the bottom touch the 5th point at the top. So if I want to measure, so this is my one subunit. This subunit, if I want exactly half, so I'll take the 5th point. So if I draw the vertical line, this distance will be my sub of subunit part. Okay. And you have to measure, draw the line PQ. You have to, whatever may be the line you are getting, you have to draw the line PQ. This point to this point, it is P and Q you have to represent. Okay. So I'll show the problem. Watch this video link once so that you will be understanding how to do. So initially you have to calculate what is the PQ. PQ is 4.56 meters, and RF. In this problem, directly they gave RF, which is 3:200. Maximum length, maximum long enough to measure up to 6 meters. So this 6 meters again you have to convert into centimeters. Least count is the centimeter. It can measure up to 1 centimeter. You can measure. So you have to calculate LOS. So this 4.56 meters you have to divide into 4 meters, 5 decimeters, and 6 centimeters you have to measure. And RF already they gave us 3 by 200. Length is 6 meters or 600 centimeters. Okay. And then least count is 1 centimeter, because least I can measure up to 1 centimeter on this scale. And next is the LOS. Yeah, I have to find LOS. RF into maximum length, 3 by 200 into 6 into 100, it comes as 9 centimeters. So this 9 centimeter line you have to divide into 6 meters, because maximum length is 6 meters. So you have to divide this 9 centimeter into 6 equal parts. Okay. So this is my 9 centimeter line. On this 9 centimeter line, I have divided into 6 equal parts. First part will be 0. First part 0, second part 1, 2, 3, 4, 5. So this is 0 to 5, and this, my sixth part is here. 0 to 10 is my sixth part. Then what I have to do is, I have to take this vertical line as 50 mm. 50 mm, each I have to divide it into 5 mm. Each one I have to divide into 5 mm. Okay. Then from, I can know that 0 to 4 is the 4 meters. 0 to 4 is the 4 meters. And then I have to measure 5 decimeter. So on the decimeter scale, this is my fifth line. So my fifth line, I have to draw this line. This is my fifth line. And from the centimeter scale, this is my centimeter scale. Vertical line is the centimeter scale. From the centimeter scale, I have to see the sixth point, where the fifth point of decimeter scale and sixth point of centimeter scale is touching. That is my P point. And from this distance is the Q. And this distance is the Q distance. PQ distance. Okay. So generally what happens is, if I draw a vertical line, this is my vertical line. This is my vertical line, and this is my another vertical line. So out of this vertical line, only this distance is 6 centimeters, and another rest of the part is another 4 centimeters. So here I'm highlighting only 6 centimeters. I'm not highlighting complete. So where the fifth point of decimeter scale is touching the sixth point of centimeter scale, that is my point, initial starting point, and the end is the 4 meters, because 0 to 4 is my 4 meters. Okay. Yeah, any doubts you can unmute and you can ask. Any doubts you can unmute and you can ask. This is the previous problem I'm explaining. So in the plane scale, draw 2 problems. In the diagonal scale, draw only 1 problem. Only sixth one. Sixth one is only this one in the diagonal scale you have to draw. Yeah, any doubts in the previous scales you can ask. So next one is the Vernier scale. If you see the plane scale, you can measure only 2 units. If you see the diagonal scale, you can measure 3 units, 3 consecutive units. If you use the Vernier scale, also you can measure the 3 units. Same, three consecutive units you can measure with the diagonal scale. Okay. Okay. So plane scale and Vernier scale. On the Vernier scale, you have plane scale and Vernier scale. Plane scale consists of main division and subdivision, and on the Vernier scale, you can measure sub of subdivision on the Vernier scale. Okay. So generally, what we do here is, I will explain once again. So this is my plane scale. On the plane scale, this is my first division, and rest are the other divisions, equal divisions. So first one will be 0, 1, 2, 3, and 4. So similarly, I need to again divide. So I will divide again. So same thing I have drawn here. So this is my subunit. Okay. So what the Vernier has done is, he has seen such a way that he has taken, this is my 0th point. From the 0th point, if I go backward, suppose this is my 0th line. If I go backward, is nothing but I am adding +1. So total will become 11 here. If I am going forward, then -1. It will become 9. So what he has done is, he has taken the 9th table, he has taken the 11th table. So in the backward Vernier, he has taken the 11th table. In the forward Vernier, he has taken the 9th table in order to generate. So if you see the 9th table, it will be like 9, 18, 17, 9, 18, 27, 36, like that. Serially you have this. So if you want to measure anything, he'll check the last digit. He'll check the large, suppose 6. He'll subtract with 36, 0.36. He'll subtract with 0.36 and he'll make this one last second decimal as 0. So that rest of the things, suppose he want to measure 2.1. So what he do is between 2 and 3, we'll again divide into 10 equal parts and this will become 2.1. He'll add 2.1 plus 0.36. Then he can directly measure that it is 2.47. If you want to measure 2.47, he can use this one. If he uses the 11th table, what he do is, suppose same he want to measure 2.47. If you want to measure 2.47, he'll subtract 0.77. 11th table, you can 7th will be 0.77. So we'll make the second decimal as 0. Then 14 minus 7, we'll make it as 7. So it is 1.7. So what I have to make is 1.7 plus 0.77. It will come as 2.47. So like that, we have to use in the Vernier scale. So what he has done is either he has added one same object or he has reduced. If you see here, he has added one this extra. This will become 11th table. Already I have 10 equal parts. And add one more part. It will become 11th part. So out of this 11, I am dividing into 10 equal parts. So 11 by 10. Each one become 1.1 centimeter or 11 centimeter. Suppose if I want to measure 77.77, similarly what I have shown. So I will highlight this 77 from this side. So here to here it is 0.77. And from here I can highlight 1.4. So that total 1.7, same it will become the value. Okay. That is a Vernier scale we use here. Okay. Once watch this video, so you will be understanding. So in this scale, what we do is we add one more unit. We add one more subunit, and we take the vertical height as 5 mm, and that 10 equal parts. So this is my 10. I'm adding one more. So total it become 11 parts. This 11 parts I'm dividing into 10 equal parts. So once watch this video. So in this video, they are saying that RF is 1.25, RF is 1:225, and maximum length is 4 and maximum length of the Vernier scale is 4 meters. From the 4 meters, you have to measure 2.39 meters and 0.91 meters. Okay. So can anyone tell me if I use for the 2.39, if I use the 11th table, what is the backward Vernier? What is the value? How I can divide this one? 2.39 meters.
1.40 plus 0.99.
1.40 plus 0.99. Okay. So 0.99, you have taken the forward Vernier. Okay, you have taken the backward Vernier. So I have to subtract 0.99. So from the Vernier scale, I have to highlight only 0.99. On the plane scale, I have to highlight 1.40. Similarly, 0.91 by using the forward Vernier, by using the backward Vernier.
Zero 0.11, 0.8.
0.8 meters plus 0.11 meters. Okay. So I'm using same 11th table. So I'm subtracting 0.11. So it will become 0.808 meters plus 1. Same thing he will use in this one. Okay. Pause the video.
division into again 10 equal parts, which represents 0.1, 0.2, 0.3, 0.4 up to 0.9 and 1 meters. Okay, and give the numbering as 0, 0.1, 0.2, 0.3 up to 1 meter. Now, for constructing the Vernier scale, take an additional dimensional division, one division, take the extra division to the left side of the Vernier scale. Here, first I am representing the units. Main units are in meters and subunits are also in meters like 0.1, 0.2, 0.3. Next, we can also divide the remaining divisions also into 10 number of equal parts for representing the decimal values of the meters. That is 0.1, 0.2, 0.3 meters. Next, take an additional division to the left side of the Vernier scale rectangle and divide the distance, that is 0 to an additional division up to 0 to additional division, and take another rectangle above that and divide it into 10 equal parts. So here each division represents 0.11 meters. How it could be means, here we have taken extra point as 1.1. By considering the length of 1.1, we have constructed a rectangle, small rectangle, that is Vernier scale, and we have divided it into 10 equal parts. That means 1.1 by 10 means 0.11. So here each division represents 0.11 meters. So give the numbering as 0.11, and this second division will be 0.22, 0.33, 0.44, 0.55, 0.66, 0.77, 0.88, 0.99, and last one will be the 1.1. Okay, so this is the Vernier scale we have constructed. By using this, we need to show 2.39 meters and 0.91 meters. So for that, first we consider 2.39. So here, for representing this 2.39 on this Vernier scale, first we need to subtract the 9 related value on Vernier scale. So here the 9 related division is 0.99. So for take this 0.99 and subtract from this value. So when we subtract 0.99 from 2.3, we get as 0.40, 1.4 we get. Okay, 2.39 minus 0.99 means we get 1.40. So here we have subtracted 0.99. So draw a line from 0.99. Draw a vertical line from 0.99, and the remaining value is 1.4. So 1.4 means here the value is 1.4, 1.1, 1.2, 1.3, and 1.4. And from the 1.4, draw a vertical line. Okay, so this much distance will be equal to 2.39. So then draw a vertical line, dimensional line, and represent 2.39. So once again listen here, for representing this point 2.39, we have to first consider the division related to 0.09. So related to 0.09 is 0.99. So take this 0.99 and subtract from the dimensional value that we are going to represent. So 2.39 minus 0.99 means we get 1.4. So we have subtracted 0.99 and we have drawn a line, and the remaining distance is 1.4. So here from 1.4 we have drawn a vertical line. Then the distance between these two vertical lines will be the desired dimensional value, that is 2.39 meters. Okay, and similarly we need to represent 0.91. So for this also, first consider the division that is related to 0.01. So here 0.01 related division is 0.11. Take this 0.11 and subtract this distance from 0.91. Okay, so here we have subtracted, we can subtract the value 0.91. subtract the value 0.11 from 0.91. When we subtract that, we get 0.80. Okay, so first draw a line from 0.11, then draw another line from 0.80. So where is the 0.80? Now we have to represent 0.80. So remaining distance is 0.80. Means here the first division is 0.1, 0.2, 0.3, 0.4, 0.6, 0.7 and 0.8. So this one is the 0.8. So when we draw a vertical line and represent the dimensional value, it can become 0.91. 0.80 plus 0.11, that is equal to 0.91. So draw a vertical line from 0.8. Okay, then draw the dimensional line in between these two vertical lines, then represent the dimensional value, that is an.
Yeah. So in this case, so from here you have to measure 99 0.99 plus 1.4, total become 2.39, because we have to give from the 1.4 plus 0.99 will become 0.91. So like this you have to calculate in the Vernier scale. Okay, you have to add, I'm adding one more extra part, so that it will become 11 parts. This 11 parts I'm going to 10 equal parts, each will become 0.11 part. Okay, like that we have to. Okay, yeah. So this is a problem you have to draw in the drawing sheet. So two problems from plane scale, one problem from diagonal scale, one problem for Vernier. In this problem, they mentioned RF equal to 1:40, and you are measuring 3 units. One is meters, decimeters, and centimeters. Least count is centimeter, and maximum length it can measure is 7 meters. You can measure maximum 7 meters, and from the 7 meters you have to measure 5.76 meters on the scale. Okay. So there are few things. Distance to be measured is 5.76. So we have to divide this 5.76 as 0.66. I have to minus 0.66. If I subtract 0.66, I'll get 5.1 meters. So I have to it will divide as 0.66 meters from the Vernier scale, 5.1 meter from the plane scale. Total will become 5.76 meters will be the value. Okay. And next is the RF. RF they directly mentioned 1:40. So you can take directly 1:40. If they're not giving, you have to calculate. Numerator by denominator, you have to calculate what is the actual drawing size by actual size of the object. You are drawing this much size on the drawing sheet, but actual size is this one. So numerator by denominator, you have to calculate, you will get RF. Next, maximum length is 7 meters. You have to convert meters into centimeters. It will become 700 centimeters. Least count is 1 centimeter. Okay. Next, you have to calculate LOS. LOS equal to RF into maximum length. We have to multiply RF into maximum length. 1/40 into 7/700. It will become 17.5 centimeter. Okay. So you have to draw the LOS. This LOS AB length equal to 17.5, and you have to divide this AB into total 7 parts, because maximum length is 7. I have to divide 7 equal parts. So first one 0, 1, 2, 3, 4, 5, and 6. So this is the 6 parts, and this one is the 7th part. Okay, so I have to make this as my distance. Okay, first construct a plane scale, then divide this into 10 equal parts. Divide this into 10 equal parts and add one more part. Measure with the scale. What is the 10 to 9? What is the distance? Add the same distance and create Vernier scale, and divide this into 10 equal parts. Okay. And the 6th part. Suppose this is my 6th part. I need to highlight. my 6th part, and this distance is 0.66. 0.66. So this is my meters. This is my meters. This is my centimeter. This is my decimeter, and this is my centimeter. So from this centimeter, I have to highlight 66 centimeters. and from the main scale I have to highlight 5.1. So what I have to do is, again I have to divide 5 to 6 into 10 equal parts, because again you have to repeat the repetition. So from here I have to highlight 5.1. So this 5.1, so this will be 5.1 meters. This is 0.66 meters. Total become as 5.76 meters will be the total value. So like this you have to draw. So no need of dividing 0 to 1, 1 to 2, 2 to 3, 3 to 4. No need of dividing. Only divide 5 to 6. In between 5 to 6, make 10 divisions and highlight 5.1. So you are highlighting 5.1 meters. You are highlighting 0.66 meters or 66 centimeters. Next, total distance is 5.76 meters. Okay. Any doubts, you can unmute and you can ask. Anyone, any doubts, you can unmute and you can ask. And this is what your seniors have drawn. They are divided 5 to 6 again, and they have highlighted 5.1. 5.1 plus 0.66. Total becomes 5.76. This is a meter value, this is a decimeter value, and this is my centimeter. Okay. And you have to write RF value, LOS value. Okay. Yeah, any doubts, you can unmute and you can ask. Any doubts, you can unmute and you can ask. And there are few problems, 9 and 10. You can read it on your own. If any doubts, you can ask me in the next class. Only draw 2 problems from the plane scale, 1 problem from diagonal scale, 1 problem from Vernier scale. This is the problem you have to draw from the Vernier scale. Okay. Yeah. Any doubts, you can unmute and you can ask. Anyone, any doubts, you can unmute and you can ask. Okay. I hope no doubts. So I'm going to next topic. Yeah, I'm going to the sheet 5. Sheet 5 is the principle of orthographic projection. Sheet 5 is the principle of orthographic projection. So what is meant by ortho? Anyone know what is meant by term ortho? Ortho. O-R-T-H-O. Anyone know what is meant by the term ortho? Graphic is nothing but the representation. And projection. What is meant by projection? And what is the principle of projection? Ortho. So have you seen orthopedic? They will say few doctors as orthopedics and all those things. So ortho is nothing but the 90 degrees. Ortho is nothing but the 90 degrees. So if there is any object, suppose in your class there is a projector. So what happens is, this is my board. So this is your drawing board. In the drawing board, I will be placing the projector screen. This is my screen. Projector screen, I will drag it down. And at the top, you have a projector. At the top, you have a projector. From this projector, a light will pass. From this projector, a light will pass. And it will project. Whatever I am projecting, it will project. So in the projection also, what we do is, there is an object. There is an object which needs to be projected. So if I pass a light at a 90 degrees, so 90 degrees, this object will again replicate at the back. Okay. This object, same way it will replicate at the back. Okay. Suppose this is a rectangle. Suppose this is a rectangle. Suppose this is a rectangle and has its parts of A. Example, this rectangle has ABCD. ABCD. So now on this rectangle, I am passing a light, and this light, it will follow a shadow on the wall, and it will show the same object ABCD. Okay. So this is the orthographic projection. It will be at 90 degrees. If you are projecting anything at a 90 degrees, it is called as orthographic projection. Okay. So generally, all the objects, whatever we see, all the objects, whatever we draw on Indian drawing, it is a 2-dimensional, because your drawing sheet is a 2-dimensional, and that's 2-dimensional. But generally, the objects are 3-dimensional, length, width, and thickness. But your drawing sheet only 2. So in order to represent a 3-dimensional to 2-dimensional, we use the orthographic projection. This orthographic projection will be based on the principle of projection. What are the principle I have explained earlier? Same principle. What the principle is? Straight lines are drawn from the various points of the object. Suppose I have a triangle. Triangle only has ABC. So only this ABC will be projected on the other side. On the projector, it will project. Okay. On that plane. I need to have a plane at the back side. I need to have a plane at the back side. On that plane, on your projector sheet in your class, you have a projector sheet. So on the projector sheet, it will project. Whatever the shape is there, the shape will be projected. Okay. And you will generate the points. So if this is the I'm projecting, I'll generate the points. If I join all the points, then I can generate the object, final object I can generate. Same replica of the object I can generate on the projector. Okay. That is called the projection of the object. Okay. And the lines. So what are the lines are joining the object? Those are called projectors. These are called projectors lines. Okay. And this is called projection of the object. Whatever the object is created on the back side of the plane, it is called projection of the object. And these lines are called projectors. Okay. Then there is a division. This is a division of projection, not orthographic projection. Projection divided into two types: perspective and parallel. And perspective has two types: linear and actual. And this
So we have to draw this.
No need. Next, there are perspective are two things: linear and actual. Next, parallel. Parallel divided into three types. One is oblique, axonometry, orthographic. This axonometric divided into isometric. So in the 5th unit, you will find convert an object into isometric to orthographic, and orthographic to isometric will be getting now. Okay. Next is we are discussing about orthographic projection. In this orthographic projection, again divided into 4 types. Divided into 4 types. First one, first angle method, second angle method, third angle method, and fourth angle method. Okay. And out of all these things, we learn only first angle method. Generally, we learn first angle method and third angle method, and we use only first angle method. And isometric, you will be learning in the 5th unit. You will be learning isometric projection. Okay. So it is orthographic projection. This is isometric projection. You will be learning. Okay. So whenever the projectors are parallel is nothing but 90 degrees. Whenever there are 90 degrees to each other on the perpendicular plane, it is called orthographic projection. Okay. Whenever it is perpendicular 90 degrees, it is called as orthographic projection. Okay. Okay. So everyone look at the video. I'm stopping the share. So everyone look at the video. So what we do is, this is my book. So what I do is, this is my plane. I need to consider the plane. This is my horizontal plane. Whenever the plane is horizontal, this is my horizontal plane. And I consider this as my vertical plane. This is my horizontal plane. So whenever you are making the projection, there are 2 types of plane. One is horizontal plane and another is vertical plane. And if I lift this one, then here the horizontal plane and vertical plane both are touching at the point. The horizontal plane and vertical plane both are touching at the point, that is called axis reference plane. On the reference line, both horizontal plane and vertical plane are touching each other. Okay. So there are 2 types of planes. One is horizontal plane and vertical plane. Generally, we consider 2 planes, horizontal plane and vertical planes. And there are different types of planes. We need minimum only 2 planes. In order to represent an object. So those 2 planes, PLANES, are called as, generally we take horizontal plane and vertical plane. Okay. And these 2 reference planes intersect at each other at 90 degrees. So this is my horizontal plane. This is my vertical plane. Okay. If I am making it as 3D, this is is my horizontal plane and this is my vertical plane. These both are intersect at a common point. This point is called reference line. These two planes. This is my horizontal plane. I can write it as HP. Horizontal plane I can write it as HP, and vertical plane I can write it as VP. Horizontal plane, vertical plane. So here, if I draw any object, this object will project here like this. It will project on horizontal plane, and it will project on vertical plane. It will project on vertical plane. Okay. So there are different types of reference planes. One is vertical plane or frontal plane, because if you see the front, this is your vertical plane. This vertical plane is the front of the object. This is the object. This is the front of the object. It is called as a vertical plane VP or frontal plane FP. So we called as VP, vertical plane. This we called as HP. Okay. Next plane is the horizontal plane HP. This is called horizontal plane. And next one is the profile plane. So profile plane is nothing but, suppose if I want to measure this side, so this is my profile plane, PP we call it as, nothing but the side view. Suppose this is my object, this is my front view of the object will be projected on the vertical plane, and my bottom or top view of the object is projected on horizontal plane, and my side view, this is my side view. My side view will be projected on profile plane. Okay. Minimum two planes are required. One is vertical and horizontal. But if the side view is complicated, then I need to see the side view of an object on the profile plane. Okay. Next, note intersection of VP and HP. So where the VP, vertical plane, and horizontal plane are touching, that is my XY line. Where my vertical plane and horizontal plane are touching, that is my XY line. I have to write here X, I have to write here Y. Yeah, any doubts? 8, you can, any doubts? 8, roll number 8, unmute and you can ask. Any doubts? Roll number 8. Yeah. So there are total 2 planes. One is vertical plane and horizontal plane. If you want to see the side view, you need to add one more plane called profile plane. Okay. And wherever the VP and HP are touching, that is called XY line, which is called reference line. And intersection of VP, HP, and AVP. So wherever the VP is touching, AP is touching. So wherever the VP, HP, and PP profile plane is touching, that is called X1, Y1. This is called X1, Y1. X1, Y1 line. This is X1. This is Y1. That is the line. Okay. So I'll draw once again. So this is your vertical plane, and this is your horizontal plane. So where the vertical line and horizontal plane are touching, that is called XY line. Okay. And similarly, where the vertical plane, horizontal plane, and this line is called as X1 line, and this is the line. This is starting of the line, and the ending of line you have to write Y1 line. Okay. Next, understood the concept or any doubts in this one? If you understand this one, then only you can understand the other concept. And sheet 5 is the most important in the drawing. If you understand sheet 5, then only you can understand next 6, 7, 8, 9, 10, 11, 12. All the sheets you can understand only if you understand sheet 5. So listen carefully. Understood? Any doubts in this one? What is meant by vertical plane, horizontal plane, profile plane? Okay. So if an object, if I want to project an object, I can project upon 6 views, such as top view, bottom view, next front view, rear view, next side view, right hand side view, and left hand side view. Okay, so like this I can see the object at total 6 views. Okay, similarly my front view. So this is my object. For the object, this is my front view, back side is side view. Next, this is my left right hand side view, this is my left hand side view. Similarly, top view and bottom view. You have total 6 views of an object, which is I will also show the image. So this is my object. So the object shows different in different views. Front view and back view almost show the same sign. Bottom view and top view show the same way. And left hand side view, right hand side view show the same. So minimum you require 2 views. Minimum you require 2 views in order to generate a simple object. If it is a complex object, then you require total 3 views. Okay. So if you know the front view and top view, you can generate an object. If it is a simple object, if it is a complex object, you have to know the front view, top view, and either of the side view, left hand side view or right hand side view. Okay. So this is my object. If I see in the front view, I can see this in the front view. I can see this one in the front view. I can see this one in the front view. I can see this one in the front view. Okay. If I see from the top view, I can see this one in my top view. I can see this one in my top view. This part I can see in my top view. Similarly, if I see in the side view, I can see this part. I can see this part. So that is the part projected here. This part and this part is projected here. Okay. If I'm seeing the front view, I can see this part. I can see this part. I can see this part. This part is projected here. Similarly, if I see the top view, this part is projected here. And what are this part? This shape is there. This shape is projected here. Okay. Write down this theory note compulsory in your observation notes. Okay. Whatever I gave the theory notes of unit 5, write down the unit 5 theory notes. So minimum 2 views or 3 views are required for generating a complete object. If you want to generate a complete 3D object on a 2D shape, on the 2D drawing sheet, minimum 2 views or 3 views compulsory you need to require. Okay. While drawing on the drawing sheet. Okay. Yeah. So everyone raise your hands. I'll be taking the attendance. Everyone raise your hands. Anyone not raising the hand will be marked as absent. So you have to draw this one. I will show how to draw. First, draw this vertical line. Next, give it an angle 30 degrees or 45 degrees. Draw the line and project this line till here and join this one. Then take the XY line. Take the XY line and draw this line. This line and okay, then join this one. Join this one and erase this line. This is overlapping. What are the lines are overlapping? Erase this line. Okay, and erase this line. Overlapping lines. Okay. So this is my vertical plane. Only 33 participants raise their hands. Others also need to be raised their hands. And this is my horizontal plane. This is my horizontal plane. And the angle is 90 degrees. The angle is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Total is 360 degrees. Okay. Yeah. If you are not raising the hands, I will ask you to on the videos from next class onwards. Everyone need to raise their hands. Yeah. Only 37 participants raise their hands. Okay. So complete this sketch in your observation notes by the Saturday class. Complete this one and submit the scales sheet by Monday. By Monday evening, submit the scales sheet. Okay. Yeah. I'm lowering all the hands. Yeah. Any doubts you can unmute and you can ask. Any doubts you can unmute and you can ask. If no doubts, you can leave the meeting. The class has completed. I will take the class on Saturday. Any doubts you can unmute and you can ask. No doubts, you can leave the meeting. Any doubts you can unmute and you can ask. No doubts, you can leave the meeting. I hope no doubts. So I'm ending the meeting.